This mini-course has been prepared within the scope of the IGCP 667 World Map of the Origins project. I will talk about Ophiolites in particular with examples of the Eastern Mediterranean Ophiolites in the Anatolian Microcontinent, Turkey. Ophiolites were firstly defined by the Steinman assemblage, composed of basalts, gabbros, and serpentinites. Coleman designed that abducted fragments of the oceanic lithosphere onto a continental margin during orogenesis, displaying distinct tectonic setting of igneous origin. Also, some ophiolites contain well-preserved fossil transform faults and fractured zones representing mid-ocean spreading ridges and allowing the formation of an oceanic lithosphere. For example, the east-west striking Aracapas fault zone in the southern Troodos. You see ophiolite seconds, bottom to top, tectonosite pedotite, cumulite pedotites, cumulite gabbro, sheeted dikes and pelagiogranite, pilau basalts, pelagic seconds. In this here, a lot examples from the İzmir, Ankara, Erzincan, Sutur zone ophiolites. Their structural agriculture is named by layer cake pseudostratigraphy here and is made by tectonosite pedotite or upper mantle pedotites, namely Habsburgite danite, cumulate pedotites, for example, danite, verlite, pyroxenite overlying bilayer and massive gabbros, sheeted dikes and pelagiogranites, volcanic seconds, namely pilau basalts, and a sedimentary cover, i.e. pelagic seconds, bottom the top. Transition from upper mantle, namely tectonosite pedotite, to cumulate pedotites represent petrologic moho, Mohorovic discontinuity, while transform from cumulate pedotites to gabbros indicate seismic moho. This second form by these rocks is known as Panrosa type ophiolite seconds. The mafic-ultramafic assemblage formed a result of the seafloor spreading in mid-ocean ridge or subduction zone oceanic environment during different stages of the Wilson cycle evolution. Ophiolites are classified in terms of spreading rates of formation in an oceanic setting beneath the slow floor spreading and fast floor spreading ridges. The Panrosa type oceanic crust with a layer cake pseudostratigraphy is significantly different from the Hess type oceanic crust of slow seafloor spreading ridges. Ligurian type ophiolite with a Hess type internal structure represent a relatively in situ fragment of mid-ocean ridge generated oceanic lithosphere beneath the slow seafloor spreading ridge system, like the mid-Atlantic ridge. The Ligurian type ophiolites are representing lazulite type ophiolite seconds that are mainly made of largely serpentinized pedotite intruded or covered by small to moderate volumes gabbros, dikes and gabbros breccias and pilau basalts. Otherwise, oceanic crust such as the Troodos, Semail, and İzmir, Ankara, Sutur zone ophiolites form at fast floor spreading non-rifted ridges. These Mediterranean type ophiolites display Panrosa type ophiolite seconds, also characterizing Habsburgite ophiolite type, namely hot type ophiolite seconds here. Besides, ophiolite studies of the modern subduction zone environment in the Western Pacific have provided important constraints for the ophiolite formation by seafloor spreading in the forearc, bacarc settings in the suprasubduction zone environment. Paleozoic to Mesozoic ophiolites from Turkey are formed in the rift reef, seafloor spreading, and subduction zone environments in the Tethyan seaways. Therefore, ophiolites display variety in origin from continental rifting and initial seafloor spreading to intra-oceanic subduction zone, spreading with mid-ocean ridge basalts to suprasubduction zone affinities. Ophiolites are generally found along the suture zone. In here, you see suture zone in Turkey. In continent are continent collision types and accretionary type orogenic belts. In Turkey, the orogenic belts associated mainly with continent-continent collision are observed, and minor arc-continent collision types, for example, Kura ophiolite. In here, pillow basalt of Kura ophiolites covered by Upper Jurassic Lower Cretaceous limestone in the Pontic Belt, northern Turkey. Pontic Belt here. And accretionary type orogenic belts, for example, Ankara melange, another Karakaya complex belonging to Sakarya continent. Here, Sakarya continent, Ankara melange here, represent accretionary type orogenic belt. It has also been observed that in some mountain belts have evolved from accretionary orogenic belt to collision type orogenic belt. For example, Eldivan ophiolite, Ondo, İzmir, Ankara, Erzincan, suture zone. These orogenic belts containing ophiolite knobs indicate closing oceanic basins and amalgamated plates or accretionary terrains. Mafic, ultramafic ophiolite assemblages are also observed in the surrounding of Dağ-Küplü Mound, northern Eskişehir city, western part of the İzmir, Ankara, Erzincan suture zone. Dağ-Küplü ophiolite is underlined by a melange containing blocks of serpentinizite, peridotite, dolerite, basalts, chert, radiolite, neritic pelagic limestone, and metamorphic rocks in serpentinite and or mastan matrix. Upper mantle peridotites, as the dominant ophiolitic rocks in the field, are composed mainly of Habsburgite with the danite bands and lances and disseminated chromite deposits. The Orhaneli ophiolite mainly contains ultramafic cumulates with danite, verlite, and pyroxenite. Cumulate gabbros overlying the ultramafic cumulates are displayed alternating plagioclase and clinopyroxene-rich layers. Some of the main ophiolite emplacement can help us to determine the major orogenic events. For example, the Paleozoic ophiolites along the Appalachian Caledonian orogenic belts form in the Iapetus Ocean between the North America and the Baltica-Avalonia continents. The Variscan ophiolite in the Spain, Central Europe, and Northwestern Africa developed in the Rake Ocean between Baltica, Avalonia, and Gondwana continental units. The Altaid Ophiolites within the Central Asian oceanic bed are related to the glacier of the ancient Paleotethys Ocean in the late Triassic by the Cimmerian orogeny. Paleozoic Ophiolites are also found in the Uralian orogenic bed caused by the glacier of the Paleonic Ocean between the East European block and the Siberian continent. In the Permian, the Jurassic Cretaceous Ophiolites of the Neotethys Ocean related to Alpine, Himalayan, Tibetan orogenic system extend from the West Europe through the Central East Europe to the Southern Asia and the Indonesia region in the most east between Eurasian and Gondwana plates. Ophiolites are fragments of an ancient oceanic lithosphere along the orogenic bed and an assemblage of the oceanic crust drugs to upper mantle rocks. Oceanic crusts are generally composed of gabbros, schistitites, and pelagiogranites, massive pilobasalts, and pelagic seconds. Upper mantle peridotite are represented by mostly Hasbrookite and danites, Cuminate danites, Everlites, pyroxenite, and gabbros indicate petrologic and seismic moho discontinuity. Ophiolites are found within mid-ocean ridge or subduction zones, i.e. Farark and Bakark tectonic environments. Ophiolites were emplaced into continental margin during continent-continent collision and or subduction accretion events.